In preparation for talking about the actual gas laws, these mathematical equations that relate different variables for gases, we need to worry about two things. One is we need to make sure we know how to convert units for temperature, and we also need to understand the difference between an inverse and a direct relationship between values. So there are three common temperature scales that are used. Fahrenheit is the one we're most familiar with. Okay, that's what we usually hear things about temperature in the weather. Celsius is also used heavily in healthcare, and so being able to convert from Celsius to Fahrenheit is a critical skill for anyone in the healthcare field. And in science, we typically use a Kelvin. And so this diagram just shows you some relative values, and so you can kind of compare them. So if we look at body temperature, for example, in Fahrenheit, that would be 98.6. Celsius is 37, and in Kelvin is 310 Kelvin. And the key thing about Kelvin is that there is no negative values. So we can have 0 as our lowest one. So now we'll look at the actual equations that we use to convert among these three values. So these are the two equations that we'll be using to convert between units of temperature. Now you may see different versions of this equation here. They're all equivalent. It really doesn't matter which one you use. So if you already know one to go from Fahrenheit to Celsius, by all means, please feel free to use that. And so we basically put our temperature in Celsius. 9/5 times that value plus 32 gives us our temperature in Fahrenheit, or we can put a temperature in Fahrenheit, and we have to do a little bit of algebraic rearrangement to solve for that temperature in Celsius. Going between temperature in Kelvin and temperature in Celsius, this is our temperature in Kelvin, is a little bit easier. We take our temperature in Celsius and we simply add 273.15 or subtract it from the temperature in Kelvin to get back to Celsius. And the reason we have to worry about Kelvin is because when we look at those equations involving gas laws, what we're going to see is that we actually have to put all of our temperatures in units of Kelvin. So let's look at an example where we have a temperature in Fahrenheit that we want to convert to Celsius. So let's say patient comes in with a temperature and they report it as 101 degrees Fahrenheit. And we want to figure out what that is in Celsius. So we use our equation and we plug in the values. So we have 101 degrees Fahrenheit equals 9/5 times the temperature in Celsius plus 32. So we need to go back and think about our algebra. We want to solve for the degree C, which means we need to move the 32 over to the other side of the equation. So I subtract 32 from both sides, and we get 69 on the left side equals 9/5 times the temperature in Celsius. Now we need to multiply both sides by the reciprocal of this fraction. So if I multiply by 5/9, okay, now what we see is that the 9/5 and the 5/9 cancel each other out. And so we have 5/9 times 69. And we get 38.3, or 38 for sig figs, equals the temperature in degrees Celsius. Now, given what we know about normal body temperature, which we said was 98.6 degrees Fahrenheit and 37 degrees Celsius, this seems like a reasonable value. So before we look at gas laws, what we want to look at are direct and indirect relationships. Now these two graphs are just examples and they're not necessarily based on real data. They were just examples illustrating this point. And so what we see in the graph on the left is that as self-esteem increases, paranoia decreases. And this is known as an indirect or inverse relationship. So as one thing went up, the other thing went down. And when we show this graphically, okay, we could show this as either P is proportional to 1 over S. So paranoia is proportional to the inverse of self-esteem because we're showing that's an inverse relationship. On the other graph, what we see here is a direct relationship. And so what we see is that as the years in school increases, our expectation of a salary would also increase. And the way to show this in a mathematical equation is, in this case, salary will be proportional to years in school. And so the proportional doesn't mean those two things are equal to one another. It just means they're proportional to one another. And we'll see some specific examples of this when we look at the gas laws.